Revisiting the aldol condensation, this time in acidic conditions. So first step of this would be if we're an acid, so acidic conditions mean we need to be an acid. First step, we need to pick up a proton. So I'm going to reach over from the, in this case, aldehyde as an actual example. Pick up a proton, the electrons get pushed over to the oxygen, and we'll have, again, in equilibrium conditions where we get this protonated aldehyde, so plus charge on there, and that's in resonance with, again, the OH will be present instead of the C double bond OH protonated, but I shift where my plus charge is. So that is just moving electrons up to here, leaving the plus charge down here. And then that's our protonated carbonyl. So what will happen with this is water will remove a proton, the electrons swing down here, and I get my enol. And of course that was a catalytic process, and so I get my acid back. Now let's consider that we've formed the enol. I want to add that enol to something else. So that something else in these conditions would be a starting material that didn't become an enol. So I could imagine then electrons coming from this oxygen, and that pushes electrons from the alkene to attack the carbonyl of a neighboring atom. And because this was in acid, this was already protonated, so we'll leave that as a plus. And then what we should get from that, again, equilibrium conditions, will be this resonance stabilized intermediate. So we'll just write all these things in. Still, now there's a plus charge on that oxygen. We have a bond to the carbon that was originally there. And now I have a new bond to this other, what was the aldehyde. So O and H, because it was protonated, and there's our CH3. So that new bond right there formed as the result of the enol attack. So that would be this arrow right here shows the formation of that bond. So continuing along here, we have a resonance form to write where these electrons move. Oops, I did that wrong, and you know how you know is because this is a positive oxygen, and so I need to move electrons toward that, and so I'm going to delete that arrow, so it's going the wrong direction. We need to start where the electrons are, and it looked like I started there, but they need to end where I'm missing some, which would be a partially positive charge, a full-on charge on that oxygen. So if I do that, I have this carbon with a plus charge on it because I moved electrons away from that. And then this carbon has its hydrogens, and it has a bond to this other carbon. That's our new bond again, right there. And an OH and a CH3. So there is another resonance form that will highlight here. This is what's different. Okay, so continuing on, this again is our resonance stabilized intermediate after attack by the enol. Okay, so I basically just started over here. And if I continue, deprotonation step, because this is water, can come along and remove the extra proton here. So I'm going to draw in the water. We'll give that a different color. There's water present in these conditions because this is H3O+, acid catalysis. So that water can remove the extra proton here, pushing electrons onto the oxygen. And that will give us the product C double bond O H CH, H, CH on that carbon, OH, and a CH3. So it's this carbon right here and this one that are different in the two molecules but end up forming our bond. This is our aldol product. So if we look, there's an aldehyde, a aldehyde, and this is an alcohol, the OL. And that's how we get the name. So this is plus H3O plus because these were in acid conditions. So there is one more step we should consider that happens quite easily. If I allow this to even heat up from the warmth of the reaction conditions can heat up because there's energy given off, this will form a new carbon-carbon bond. And so in acid or base, so I'm in acid here, and so I'll go back to, let's see, I will protonate this, and I'll get from that, the aldehyde is still here. And I have a CCH3 and a good leaving group now because I protonated it. And my H is still there. And so what can happen now, and this is mostly forward, not so much backward, is I'll use water in this endeavor to take a proton. Those electrons will swing in here, and this water, that's a good leaving group, will leave. And I will end up with this C. There's one H left still. That's a double bond, H and CH3. So this was my second molecule, second aldehyde back at the beginning. And now I have a double bond to it. Double bond to it. This is the condensation part. This is where we lost water, which is this water right here. So aldol condensation, and the driving force for this to occur would be the conjugation. This is alpha beta unsaturated aldehyde in this case. And that unsaturation in the alpha beta positions is conjugated. Conjugation is lower energy.